In this session, I'm going to show you ANOVA with medicine example. When you have two categories, drug and membrane, with two or more categories in each, and one independent variable, permeability. The aim of this session is to find the effect of the two independent variables on the dependent variable. It requires the data be normally distributed, but don't worry about it if your data is not normally distributed at this stage. In this data, there are three variables, two categories variable, type of drug and type of membrane, which are independent of each other, and one continuous variable, permeability. Type of drug has two categories coded as caffeine 2. Type of membrane has three categories. One is mucosa, code 2, regenerative, 3, Nylon. We'll go to the SPSS. We'll open the data. This is the data, drug, membrane, and the permeability is dependent variable. Membrane and drug is independent variable. Drug contain two categories. Membrane contain three categories. And let me show you here. Drug is 2, 1 coded Ibuprofen and caffeine number 2. Then membranes, 3 categories. Mucosa, regenerative, and nylon, 1, 2, and 3. And then open the data. We have to go to analyze, general linear model, univariate, and this is just reset. This is dependent variable. We can move it to the dependent variable area, and membrane, fixed factors, drug. Then after we move all the variable into the box, we'll go to plot, and then we put, as you can see, we have horizontal axis and vertical axis. So now we have to move the variable into horizontal, membrane and drag to the separate line, and then click continue, add, and then click continue. Then we'll go to post hoc. We'll check the post hoc here. As when we move membranes to the post hoc, select Toki, because there is equal data, equal observation. If the data is not equal, this drug, for example, 10 and this one 16, or vice versa, we can select Shafi. But because of the data is equal, so we have to select Toki. Then press continue, and then go to option, Descriptives, estimate of effect size, homogeneity test, and if you want to observe the power, then press OK, continue, and press OK. This is the output. We get the output. The first table is descriptive statistic, as you can see it here. According to the descriptive statistic table, using drug, Ibuprofen, mean permeability through mucosa membrane is 141, and the standard deviation 50.57 through regenerative membranes. As you can see it here, regenerative membrane is 25, as you can see it here, 2582. The standard deviation is 182. And through nylon membrane, as you can see it here, nylon membrane 2303, and the standard deviation 444.11. Using drug, caffeine Okay, mean permeability, as you can see, to drug caffeine mean permeability through mucosa member is 7.5, as you can see it here, 745.6, and the standard deviation 635 through regenerative membrane is 2438. Okay, and this is just a descriptive table. Then we have to move to, since the Levin's test of equality of error variance is significant, which is 0.15, say this is 0.15, is significant, which is less than 5%, we can assume that the variance is in the sample across the group are not equal. Namely, there is a significant difference between variance of the sample across the group. This may be related to the normality of the data, namely the data could have been non-normally distributed. The easiest way to deal with this problem is that we accept all subsequent p-values significant only if they are less than 0.001, rather than accepting the traditional p-value of less than 5% as significant. So we move to the test between subject, and we know that ANOVA p-value from test between subject effect table, since p-value for a drug is, as you can see it, p-value is 349, the type of drug alone, ignoring the membranes, because we consider membranes is constant, and the drug is not statistically significant because p-value 34.9%, which is greater than 5%. In this case, whether it is a Ibuprofen or caffeine has no significant effect on the permeability. For membrane, show that the type, as you can see, show that the type membrane alone, ignoring the drug, which is make the drug is fixed, and talk about membrane has significant effect, as you can see it here, p-value less than 5% or less than 1%, 0.001%. So in this case, okay, and we can see, we look to the interact between membrane and drug. As you can see, p-value is 23%, which is greater than 1 or 5% for a drug. Membrane shows that there is no significant interaction between the two categories variable, drug and membrane, or there is no significant combined effect of the two categorical variable on permeability. Now we move to the post hoc, and we look to the post hoc. As you can see it here, this is multiple comparison for post hoc test. Table is considered only if the p-value of the categorical variable having 3 or more categorical level, membrane in this case is significant. Post hoc tests explain, which means significant different from other, as there are 3 mean or in membrane variable according to the table here. As you can see it here, mucosa with regenerative statistically significant, mucosa with nylon is statistically significant, and also, as you can see here, only 2. Mucosa regenerative is statistically significant because p-value is less than 5%, and mucosa with nylon is statistically significant because p-value is less than 5%. And then we have to move to C, which is statistically significant, different from 0. And significant difference in permeability as a dependent permeability between mucus and nylon. Mucus and nylon statistically significant, and not significant difference in permeability between regenerative and nylon. As you can see, regenerative and nylon, which is 67.3%, which is not statistically significant. Okay, the last thing we have to look at to the graph. As you can see it here, this is estimated marginal mean, and this is membrane, and this is, we have the drug Ibuprofen and caffeine. The blue is Ibuprofen and the red is caffeine. Following the graph support the result described above in the table here, as you can see it. just to confirm this table here for post hoc, and this is to confirm the table regarding the drug permeability achieved using membranes, either regenerative or nylon, is significantly higher than the permeability achieved using natural membrane, which is mucosa. Within the membranes or keeping the membrane constant. Of course, when we want to find the effect of the ibuprofen on the permeability, we have to fix the other variable. It seems that mucous membranes only. However, this difference is non-significant, as we have already established above, and there is no significant effect of type of drug on permeability. And as you can see it here, mucus is the only one is significant, as you can. Okay, let me say it again. Following the graph supported the result. This graph supporting the result in the table for post hoc, regardless of the drug permeability achieved using membranes, either regenerative or nylon, is significantly higher than the permeability achieved using natural membrane, which is mucosa. Within the membranes or keeping the membrane constant, the higher the difference, the higher the difference is permeability between the drug ibuprofen and caffeine. The higher, as you can see it here, the higher difference in permeability between drug, the higher the difference in permeability between the drugs ibuprofen and caffeine, which is here you can see it, the higher, the blue line, between the permeability between the drug. In the permeability between the drug ibuprofen and caffeine is seen for mucosa membrane. As you can see it, mucosa. Okay. However, this difference is non-negative, as we have seen already. Mucosa and membrane. Let me just go to the table. Mucosa, as you can see it here, mucosa membranes only. Okay, so in this case, this is the table or the graph which represent and confirm the table for post. Okay, thank you so much.